Welcome to ChemExam Explained, where the aim is chemistry clarity exam mastery. Alright, so this video, we will be looking at a few questions that are posing some challenges where the multiple choice questions are concerned. So let's look at a few of them. So here we have a question that came in 2024. The problem is when you work it out the correct way, the answer is not there. So when you work it out the way that they work it out, you get the answer to be C. If you read the question carefully, you'll see that you're looking at group 2 metals and you're given the KSP for calcium sulfate, strontium sulfate, and barium sulfate. You should know that the sulfates decrease in solubility. The ones at the top of the group are more soluble, and as you go down the group, it becomes more insoluble. So when you work it out using the 1 times 10 to the minus 3 given for the concentration for the equal volumes, you get 1.0 times 10 to the minus 6. And with that, when you compare this IP value with the KSP values, then you'll get no precipitate for the first one because the IP is less than the KSP value. But for the other two, you'd get precipitates. But if the question is to be worked out correctly, because you're given equal volumes, you have to halve the concentrations in order to find the IP. So 10 to the minus 3 half would give you 5 times 10 to the minus 4. And the IP value for that now would be 5 times 10 to the minus 4 times 5 times 10 to the minus 4, which gives you an IP value of 2.5 times 10 to the minus 7. Now, when you compare the IP values with the KSP values in the table, you'll see that the IP would be less than the KSP for 1 and 2. Therefore, no precipitate would be formed for those two sulfates. But the IP would be greater than the KSP for barium sulfate. That's the only one that should form a precipitate. But as you can see, that answer is not there. So the answer should really be 3 only, but it's not there. I figured they only use the 10 to the minus 3 in the calculation instead of halving the values. And that's how they get the answer to be C. But the correct answer should be 3 only, but that is not there. So I guess if you see this question, you just work it the way that they got the value, but it's not really correct. Let's look at another problem. This one, initially looking at it, I got D for the answer. But after looking back at it, you see that it makes sense to change it to C, because what's happening here is that energy and frequency are directly proportional, and frequency and energy are linked to gamma because gamma has high energy. Therefore, gamma could simply replace energy or frequency here. So the best answer for this one is C. So any other paper that you saw D as the answer, please change it to C. This is the best answer. This one is causing a lot of confusion. Now, it said that the sharp increase from copper to zinc is caused by filled. You get 4s orbitals only, 3d orbitals only, 4s orbitals and 3d orbitals, 4s orbitals and half filled 3d orbitals. Now, my thinking is, if you recall chromium and copper, that the reason you half filled the 4s and half filled the 3d for chromium, you put 1 in the 4s for copper and completely fill the 3d. The reason for that is because it increases the stability, and if the stability is increased, the force of attraction between those electrons and the nucleus is stronger, which means that the ionization energy would be higher. Now, if you think of the 3d orbital when it is empty, electrons enter the 4s orbitals first. But once the 3d orbital is occupied, the 4s moves above the 3d. So you'll see that the 4s and the 3d are close to each other. And so the stability is linked not just to the 4s, but also to the 3d. Now you'll say, but why did you give this one here as the answer? Because if you look at C, you see that it is 4s and 4d. Now, if it was 4s and 3d, then that would be my answer. So if I see 4d, then I'm not going to go with 4d. The best answer would be 4s only. But as long as 4s and 3d is present, both of them affects the stability and the IE. Remember that these are not far apart, and think back to the anomalies, chromium and copper. When you half-filled the orbitals for chromium to increase stability, and when you completely filled the 3d orbital, leaving 4s with only one electron to help with the stability. So if going from copper to zinc, you put electron in the 4s. Yes, the electron went into the 4s, but because of the close proximity of the 4s and the 3d, both will affect the stability and the ionization energy. And therefore, my answer would be C, as long as 4s and 3d is present. This is the end of this short video, looking at a few questions that are posing some problems in the multiple choice. Please remember to like, subscribe, and click the notification bell so that when other videos are uploaded, you will be notified. Thank you.